and this is my week 7 teaching presentation on the topic of PHP password hash function. So I'm just going to kind of go through real quick and explain what this function does. It's pretty simple, but really important and really useful, especially when running a database. So first off, let's talk about hashing. Hashing is a type of encryption. Essentially, encryption is where you want to take plain text information and convert it into undecipherable text. The thing with hashing in particular, well, I guess with all types of encryption, they use a mathematical function to convert strings of characters into an indecipherable string of characters. But what makes hashing unique compared to encryption is that hashing is what's called a one-way encryption, or in other words, there's no way to decrypt it. With regular encryption, you have a key that you put into the algorithm that'll bring your converted plain text or your converted text back into plain text. As in, with hashing, once it's been hashed, there's no way to decipher what the plain text was originally. And what's unique about this and what's so useful about hashing, it's mainly used for authentication purposes, because if you have one word, it is always going to hash to the exact same thing. So we usually use it for comparing two different objects to see if it's the same thing. And I'll show you some examples of that as we go on here. So first off, there are 5 main rules to hashing. I'll go ahead and read these real quick. So the first rule is it is deterministic, so that the same message always results in the same hash. Kind of like I said earlier, if you hash the word cat, it will turn into the same word or the same hash every single time you try and hash that word. Next, it is quick to compute the hash value for any given message. Third, it is infeasible to generate a message from its hash value except by trying all possible messages. Again, it's something that you can't undo unless you literally try every single word, which is infeasible. Next, a small change to a message should change the hash value so extensively that the new hash value appears uncorrelated with the old hash value. This is part of what makes it so hard or almost impossible to translate back out, is that the smallest change can completely change the hash value. And I'll show you some of that later. And then lastly, it is infeasible to find 2 different messages with the same hash. Again, if you're using the current hash standards and the current mathematical equations to hash, you shouldn't ever have 2 sets of words that come out to the exact same hash. So here's a regular hash example. As you can see on the left, I have a text document just with a couple words. And then on the right, this is a bunch of different hash outputs. The bottom one is the actual hash, as in where these are just the hex of the hash. So this is what it comes out to. Now, if I go ahead and look, oh, I'm so sorry, I skipped ahead. So this is what it looks right here on the bottom right here. Now, if I go ahead and change the period right there to an exclamation point right there, you can see that the hash is completely different. I'll go back and show you again real quick the original hash and the new hash here on the bottom. As you can see, completely different hashes for just one little change. And again, it's obvious this is completely incoherent. There's no way that you're going to get that back to what I originally put in that text document. So again, it's really great at authentication to compare if one document or one text file or one set of characters is the exact same as another set of characters. And that's why it's so useful to use in our databases, especially in regards to passwords. Now, normally, if you don't hash any of your passwords or anything like that, if a hacker gets into your database, they can basically pull all the passwords and basically they can have those and use them however they want, unless we hash them, because then obviously they're incoherent and there's no way that they can get them back into plain text. So what this hash password or the PHP password hash function does is it hashes all of the incoming passwords and then stores those in the database. So instead of storing the plain text passwords, we're going to store the hashed version of the user's password. And this is obviously unbeknownst to the user. Now, when that user logs in, they'll use their regular password. We hash that password, and it should match up with the original hashed password that we have in our database. And if that's the case, it obviously lets them log on. And if not, well, a try again message or something like that, or completely lock them out. So let's go ahead and talk about the function and kind of what it does. So at the top here, you can kind of see what the parameters are for this function and how it works. So we have our function we have our function here, password hash, with 3 parameters: the password, the algorithm that we're going to use, and then additional options. So first, password, that's obviously just going to be the password that the user inputs. Next, the algorithm is going to be the type of hash that we use to convert that password into the hash that we want. So there's 2 types that are default, or that you can select. That's password bicrypt, which uses a blowfish algorithm and returns a 60-digit digest, or 60-digit characters. And then there's password default, which uses bcrypt, and that returns up to 255 characters. It's random how much that one returns, but it's recommended that you go up to 255 in the database where you store that. And then lastly, there are the options section, which allows you to add some additional encryption options where you can go ahead and salt your passwords before you encrypt them, making it even more secure. And then the cost is going to be a value used in the salt itself to determine the type of salt that you're going to use. So next, here's just kind of a brief example, pretty straightforward. So we're going to go ahead and get a password. This is obviously going to be something that we're going to have input from the user. I just use a crappy password here of just password. So then we have our options set up here. This is an array holding what the salt value is going to be in the encryption type, and as well as the value for that encryption type, which I did forget to mention, but it is default at 10. But right here, I just put 12. And then we have the password hash. So we're going to go ahead and make a password hash variable, which equals the password hash function. And then we're going to put in the password string, so this value right here. Then we're going to do a bcrypt on it. And then it's going to import the options as well. So it's going to salt it with this cost. And there we go. This password hash variable is going to contain the hash password that our user created. Now, there is a way to, compare this with a new value that they're going to enter every time that they log in. That's going to be password verify function. I'm not going to talk about this in this video. That's for someone else's presentation, but that is needed to retrieve that password back out and compare their password that they input versus the one that they initially put in when they created the account. So that's kind of all there really is to the password hash function. Here are some references if you have any questions about that. But that's all I got for you. So thank you guys so much for watching, and have a great rest of your time, and good luck this week.